Good morning, good afternoon, and good evening, everyone, from wherever you're joining us, and welcome to today's virtual demo, Kaha Telemetry System Overview. Our speaker for today is Katrina Irey, a Kaha Sales Specialist at ADInstruments, where she helps customers find solutions to their unique research questions and ensure they are successfully recording high-quality data to support their findings. Before I welcome Katrina to the floor, I wanted to cover a few housekeeping notes to help you all get the most out of your experience today. First, you can take a look at the interactivity panel at the right of your screen with 4 tabs: Chat, Q&A, Polls, and Handouts. We want this to be an interactive experience for you, so please send your questions, thoughts, and comments using the Q&A tab, and we will try to address as many of your questions as we can at the end of the demo today. When a question is added in the Q&A panel, you can upvote that question to increase its position on my list by clicking a thumbs up button underneath it. This is always helpful so I know which questions to address first. You can also explore some links and documents in the Handouts tab to learn more. Lastly, if you're having any technical issues, please try refreshing your browser and ensure you're using Google Chrome to access this event, as it is the most stable browser. If you're still having any trouble after you refresh, you can use the private chat function to communicate with me by sending a chat to Sydney, and I'll help you to troubleshoot. And now I am pleased to welcome Katrina to the floor. Please take it away whenever you're ready.
Hi, everyone. As Sydney mentioned, my name is Katrina. I'm going to be going over the Kaha Telemetry system with you guys. So today I have some slides that I'm going to be presenting that will outline the specifications and some features and benefits of the system. And then I also have a couple of videos to share at the end that go over how to set up the hardware and use some of the software tools available. So without further ado, we'll get into it. On this first slide, you can just see a general overview of the system and the main components. So you can see in the RAT system, those blue pieces of equipment are called SmartPads. Those are the receivers that are going to provide power to the telemeters and also communicate data wirelessly with them. You'll connect the SmartPads or the tBases on the mouse system, you can see them in black, to a data acquisition system. That can be anything from a power lab or another system that you're familiar with using. And then obviously you'll record that data onto a computer. And then the last component of the system is called the configurator. And I'll go into more detail on that item in the next slide. But as you can see, it's a pretty simple system, not too difficult to set up as there aren't that many components to work with. Okay, so for the configurator, it comes with a software called ConfigSoft that is used to control all of the hardware from the SmartPads and the tBases to the telemeters. There's 40 independent channels available to use. And so when you're setting up your system, you'll match the channel of the telemeter to the channel of the SmartPad or the tBase so that those two pieces of equipment can communicate data with each other. You can also put the telemeters into safe mode using the ConfigSoft software. This is available on the RAT system and allows you to store the telemeters at a lower battery level in between implantations. Also with the ConfigSoft software, you can monitor and diagnose the hardware. So if you think there's any issues with your telemeters or with your SmartPads or tBases, you can run a diagnosis on them through the software. And in the video, I'll show you guys what kind of parameters are spit out from those diagnoses. In the RAT system, you're able to turn the charging field of the SmartPad on and off. So that's something that you'll control with the ConfigSoft software, as well as setting up co-housing studies. So that's involved whether you have 2 rats in the same cage that you want to record data from, or you can also put 2 telemeters into the same animal and record that way. That would be another way to set up co-housing. We also offer an optogenetics telemeter for the RAT system. You would set those parameters and turn that on and off with the ConfigSoft software as well. And lastly, the configurator and the ConfigSoft software are only required to set up the system. Once you have all of your channels matched up to your bases and everything ready to go, you don't need to use that during data acquisition. So it's really just to get you up and running at the start of your experiments. Next, we'll go over the mouse tBases and the RAT SmartPads. So you can see again, the SmartPad is the blue, the tBase is the black. On top of these bases, you have little indentations that allow the cages to be placed on top of them. This will help make sure that the cages don't move around if the animals are running around a lot in their cages. The main benefit of the tBase and the SmartPad is that they produce a magnetic power field. You can see that is illustrated by the yellow lines on the diagram on the right side of the slide. And so this power field is picked up by an inductor coil that's located in each telemeter. That inductor coil takes the magnetic charge and converts it to an electric charge, and that is how the telemeters are continuously charged through the pads while the animals are located on the bases. Because of this charging and with the different channels to record the data, you'll want to make sure that the SmartPads or tBases are placed 10 centimeters apart horizontally from each other, so there's no interference. And again, you'll want to keep them away from metal as well, as that could cause a disruption to the inductive charging field. Because of this, if you're setting up a new lab or looking to put this equipment in your existing lab, we recommend using wooden or plastic shelving for this equipment. Again, another specification to be aware of when you're setting this up in your lab is that you want to have 40 centimeters of vertical separation between the pads as well. So I've seen labs that build their own shelving that have wooden bases, and then they stack them 40 centimeters on top of the shelving units to keep everything nice and orderly. Going back to the metal point I made earlier, we do get the question about whether or not metal cage lids or feeders could interfere. They're usually not a concern because of the charging field distance. You can see that the tBase charging field only goes about 5 centimeters above the base, and the SmartPad charging field only goes about 7 centimeters above. So as long as your animals are in those fields, in that range, the telemeters in them will be receiving power. And if you have any metal beyond that area, it shouldn't be an issue, and it won't interfere with your data or the charging. Okay, on the next slide, we'll go over the mouse biopotential telemeter. So this telemeter is shipped sterile and ready to be implanted. And we do recommend that only one is used in a single animal at a time. Because of the inductive charging ability of the SmartPads to the telemeters, you're able to sample at a much higher sampling rate with our system than most. This gives you a 2000 hertz sampling rate for recording any type of biopotential signal from this telemeter. That could be ECG, EMG, etc. And the telemeter also provides an index of activity. I'll show you this in a little bit more detail in the video, but you can see that as I move the telemeter around the pad or as the animal moves around in its cage, you'll get a signal indicating how active the mouse is. There is no battery in the mouse telemeter, so in order to record data, the mouse has to be in its cage on the tBase at all times. But because there is no battery and the power is continuously provided, you can still record for as long as your experimental protocol requires, as long as those mice are in their cages on the pads. We recommend the telemeters be used in mice that are 22 grams or larger. They are made out of a ceramic shell that's really durable and biocompatible. As you can see in the diagram, they're about 2 centimeters long, and there is a contoured side of the telemeter that helps you easily implant it into the subcutaneous area. And the contour kind of hugs the ribs of the mice so that they stay nice in place and that it doesn't irritate the animal too much. And finally, while biopotential is the only signal available right now, we are working on a mouse blood pressure telemeter. It's currently in testing at the NIH. And so if you're interested in that, please let me know. We're very excited to hopefully release that soon, and I can keep you guys updated with any developments. But as of right now, it's still in testing. Next, we'll go over the rat telemeters. So they are also shipped sterile, but a unique feature about the rat telemeters is that they can actually be re-implanted. So you can run one study for, say, about 60 days in one rat, and then you can explant the telemeter, clean it, sterilize it, and then re-implant it into a new animal. And we typically see researchers get about 4 to 5 uses of these telemeters, that being 4 to 5 animals, given they are recording for about 60 days. Once again, the rat telemeters also have a 2 kilohertz sampling rate or 2000 hertz sampling rate, which allows you to record really high quality data. The signals that you are able to record is one temperature. That's available on every single telemeter. And then we also offer biopotential, pressure, tissue oxygen, and SNA. So as you can see in that little table to the right, it outlines the different combinations that we offer. So with the SNA telemeter, you're getting a pressure as well. The oxygen telemeter just gives you an oxygen signal. And then there's different combinations of biopotential and pressure available as well. The rat telemeters do have a battery on them, so you can record data while the animals are off of the pads. The range is about 5 meters, so you can leave the SmartPads in one room and take the animals to another room and run behavioral studies, for example. As long as they're within 5 meters, you'll still be recording data through the system. We recommend that the rats you use to implant these telemeters are over 175 grams. And the telemeter shell is made of a crystal polymer material that is really durable and also biocompatible, of course. And for our rats, you'll want to implant those in the abdominal cavity. Each of the telemeters have little suture tabs on them to help you do this as well, to secure the telemeter to the muscle. As I mentioned earlier, in the rat system, you are able to set up co-housing. So you can have 2 rats in the same cage and record data from both of them at the same time. Or you can have 2 telemeters implanted in one rat if you're really interested in 3 or more signals. We do just recommend that that rat is over 350 grams so it can handle the 2 telemeters. Lastly, we also have an optogenetic telemeter available. This comes with a blue LED light and a biopotential recording electrode. So you can record ECG, EEG, whatever differential biopotential signal you would like and then also use the ConfigSoft software, as I mentioned, to run that stimulation protocol through the optogenetic telemeter. So one thing I want to highlight about the rat telemeters, and something that will be added to the new mouse telemeter once we release that as well, is the solid-state catheter technology located on the telemeters. So for those of you who are familiar with Millar, they manufacture high-fidelity pressure catheters, and we essentially take those catheter stubs and integrate them into the rat telemeters. Because of this technology, for those of you who aren't familiar, essentially there is a really thin membrane that's spread over a hollow cavity at the tip of the catheter. And every time that membrane is deflected by a change in pressure, that is translated to an electrical signal that's recorded by the system. So because of this, you're able to get really high quality data, and you won't have to deal with any motion effects, clotting, gravity, or any type of interference that could lead to noise in your signal. This technology is also beneficial in that you don't have any signal attenuation. So if you're using, say, like fluid-filled or gel-filled catheters, which are usually available on most other telemetry systems, the pressure signal will dampen as it travels through that fluid column, which can reduce the amplitude of your overall signal. That doesn't happen with the Millar catheters. You're going to be measuring pressure from the exact location that you implant it to, and you'll get really, really good quality data. This allows you to implant the catheters into different locations too. So you can record bladder pressure, intracranial pressure, tumor pressure, etc. Before we integrate the catheter stubs into the telemeters, they are rigorously tested by Millar. And Millar has also made a lot of improvements to the catheter stubs themselves so that you don't have any long-term drift in your studies. As those of you who are familiar with the Millar catheters, they are most commonly used in acute studies, but Millar has worked with us to make some improvements so that they have better results in long-term studies as well, as you can see by that graph down there. And finally, another really good benefit of the catheters is that you don't have to send them back to get regelled or refurbished. You just have to clean the implant, clean the sensor, and then you're ready to put it into the next animal. All right, so in the final summary slide, I have just some other main benefits that I wanted to highlight again. So first of all, with our system, you're going to be getting much higher quality data due to that 2000 hertz sampling rate. You get continuous sampling for a longer period of time because you don't have to worry about the battery life of your telemeters. As long as the animals are in their cages on the pads, you can theoretically record for however long you want to. We offer a wide variety of signals with the RAT system. I don't believe any other telemetry system on the market offers tissue oxygen as a signal. So that is one unique area that we set ourselves apart from. You don't have to, as I mentioned before, you don't have to refurbish the telemeters. You're able to clean them and reuse them into multiple animals, which will save you money in the long run. You get better quality pressure data with the Millar pressure catheters on the RAT system and soon on the new mouse implant. And as we saw in the first slide, because the system only has a few simple components, it's really easy to set up, both in standard mode or co-housing mode. It's just a few components to click together, as you'll see in the video. It's really straightforward. If you don't want to use one of our data acquisition systems that we offer, like the Power Lab, the analog outputs on the SmartPads and the tBases make it really easy to integrate the system with any existing data acquisition system that you use. And not only that, we also have a bunch of surgical resources and videos available on our website to support you in your experiments and to make sure you're successful using the system. I am always here as a resource. In my role, I'm going to be getting more and more training on the surgical procedures for different types of signals, and I'd be happy to share my knowledge with anyone who asks. We also have a really great customer support team on staff who can also help troubleshoot any hardware issues. So overall, we're here to support you and want to make sure you're successful using our system. All right, so those are all the slides I have to share with you guys. Now I'm going to switch over to the video and we'll watch how to set up the system.
Hi everyone! In this first video, I will be showing you the basic steps of how to set up the Kaha Telemetry system. Now as you can see, I have the three main components of the mouse system laid out in front of me, including the mouse biopotential telemeter, the configurator, and the mouse tBase. If you are using RATs, these initial steps will be the exact same to set up your RAT system. And of course, to complete your setup, you will need a data acquisition system such as a PowerLab C and the instrument interface I have here, and a laptop or desktop computer. Now, before we connect any of the hardware together, the first step we'll want to do is install the ConfigSoft software on our computer. I have mine already installed, but this is a very simple process as you will receive a USB drive with the software on it for you to easily install on your computer. Next, we will set up the configurator by first attaching the antenna to the back of the unit. This screws in nicely, and then once it's tight, you can flip the antenna up. And then next, you'll take your cable and you'll plug it into the computer. Next, we will set up our tBase by plugging our power supply into the back of the base. This other end will of course plug into a wall outlet. Next, we will connect the BNC cables from the outputs on the tBase to the inputs on the instrument interface. These cables are 4 meters long so that you will have plenty of room to connect the tBases if you have multiple units running at the same time into your data acquisition system. Next, we'll plug in and turn on our data acquisition system and then connect it to our computer. The final step of the setup process is to pair the telemeter with the tBase. Now you can see in the corner, the light of the tBase is glowing green, and this is because both the tBase and the telemeter will be shipped in what's called setup mode. To change the telemeter from setup mode to a channel, we're going to click on the mouse telemeter tile in the ConfigSoft software, and then enter the serial number that is located on the casing that comes around the implant. So we can see our serial number here is 13588. And then in the software, we're going to select our current transmission channel, which is setup. And then here we're going to change the transmission channel to 1 and click go. This note will come up saying that you'll want to adjust these transmission frequencies or channels before you implant the telemeter into the animal. Click OK, and then confirm your configuration. You'll now see that the light on the tBase is orange because they are on different channels, so they are not able to communicate with each other. The final step of setting up the system involves changing the channel of the tBase so that it corresponds to the telemeter you will be using on that base. The first thing we're going to do is remove the telemeter from the tBase. Then we'll go into our ConfigSoft software and click on the tBase tab. And just like before, we're going to enter the serial number of the tBase, which can be found on the front right corner of the unit. And from our drop-down, we're going to click Setup because we know that is the channel that our tBase is currently on. And then under Configure your tBase, from the drop-down, we'll choose Channel 1 as that's the channel we want to set it to match the telemeter. And then we'll click Go. We'll get another notification to confirm our configuration, and then we'll click OK. All right, now the tBase is on channel 1, so we'll click OK. We'll put our telemeter back on the pad, and you can now see that the light is glowing green, meaning that the tBase and the telemeter are on the same channel so they can communicate data with each other. And now we are ready to record some data. Now that I've opened LabChart on my computer, we can take a look at what these signals might look like while we're doing a live recording. So first I'm just going to press start. And as you can see, we have 3 signals being recorded. The top one is the activity, the middle one is the biopotential signal, and then the bottom one is the signal quality. So of course the biopotential electrodes are just recording some noise right now. And if I start moving it around the tBase, those noises will start getting larger, but you can also see the activity channel kicking in. And the more I move this telemeter around the pad, the more activity is being registered by the tBase. The signal quality has been set pretty standard at 3 volts, but if I take the telemeter off the pad, you can see that it will drop down to 0, which gives you an indication that the telemeter is not communicating with the tBase, and so you're not recording any data. If I put the telemeter back on, you can see that it jumps right back up to 3 volts, and we are now recording activity and biopotentials again.
For this next video, I will be showing you some additional features available in the ConfigSoft software that are specific to the RAT system, as you are able to take the telemeters off of the SmartPads, and you can also set up co-housing with the RAT system. So I have a RAT SmartPad and a telemeter connected and set up on my other desk, and the SmartPad light is showing orange. So let's say that for whatever reason, I forgot what channel my SmartPad is set to, and I want to change it to the channel of my telemeter. So I'm going to go to the SmartPad tab, enter the serial number, and then I'm going to click search for SmartPad. And the configurator found it and is letting me know that it's on channel setup. If I had more SmartPads connected and powered on, all of their serial numbers would be listed with the channels that they're associated with. So I'm going to click OK, and I'm going to come in here. My current transmission is set up, and I'm going to change my transmission to 2. I'm going to click Go. I'm going to click OK here. Now, the reason I'm changing it to 2 is because I already know that my telemeter is set to channel 2. But if you don't know that, you can click for search for telemeter as well, and it'll go through the same process. And that's also available on the mouse tBases and the mouse telemeters as well. So I'm going to click OK here. And now they're back to green, so I know everything is ready to go. Now, let's say you think there might be something wrong with your telemeter, or you're not getting the data you're expecting, or something is off. In the ConfigSoft software, you are able to diagnose the telemeter to see if there's anything wrong with it. So first thing we'll do is enter our serial number. We'll select our current transmission channel, and then we'll click Start Diagnosis. Now, you are able to save a log file of the diagnosis that are run, and if you want to share this with our technical support team to further help troubleshoot and diagnose what might be wrong with your telemeter, I would highly recommend doing that. If you click yes, it'll take you to your file explorer to allow you to choose where you want to save that file. But for the sake of this demo, I'm going to click no, and just going to let the diagnosis run. All right, so now that the diagnosis has been complete, you may have seen in that little box that it will update once every second in the log files, and it will just do it continuously in this window. So it gives us our serial number, our firmware version, what our battery level is at, if that's acceptable, if the telemeter is currently charging, and then it can also give you some diagnosis about the pressure sensors, if they're functioning, and also the oxygen sensor, if that's functioning. You may have also seen too that it just turned off the charging because the battery level is still acceptable, so it doesn't need to be continuously charging. If you're happy with everything that's being spit out, you can click Stop Diagnosis, and then the software will just stop refreshing every second and updating that data. Now, let's say you just finished an experiment with your telemeter and you are getting ready to explant it from the animal and store it for a little bit before you reimplant it into another. You can put the telemeter into safe mode very easily. You'll have the serial number up here, the transmission channel, and then we'll just click Put the telemeter into safe mode and click Go. So it'll give you 2 little notifications here. Please move the telemeter 1 meter away from the SmartPad, and please make sure the battery is charged up before storage. Our battery isn't completely charged, but that's okay. I'm just going to move my telemeter away from the pad and put this in safe mode. Now that it is away, I'll click OK. And now the telemeter is in safe mode and is good to be stored between uses. To take the telemeter out of safe mode, all you have to do is put it back on a SmartPad that is on, and it will go into active mode and will revert back to the channel it was previously on. So I have my serial number still entered here, and if I click Search for Telemeter, you can see it pops up as being on channel 2, which was the channel it was on before we put it in safe mode. I'm going to click OK. If you are curious about how to use the optogenetics telemeter, we have a specific video on our website that goes over the functions of this button right here that will show you how to set up the protocol and everything like that. But for the sake of time, I'm not going to go over that today. So let's say that you are having issues with your SmartPad. You think it is not communicating with your telemeter, or something might be wrong with the charging field or whatnot, you can also run diagnosis on that. So we're going to go to the SmartPad tab. We're going to enter our serial number again, our current transmission channel, which it was 2. And then we're going to click Start Diagnosis here. Again, you'll be prompted with the same questions about whether or not you want to create a log file. I'll click No for now. And it will tell you that the SmartPad sampling will stop when it's in diagnosis mode. Click OK. All right. Similar to the telemeter, the diagnosis is going to be refreshing every second. You can see nothing much is changing here with the serial number, the firmware version. The charging field is currently enabled. Co-housing is disabled, but if you did have it enabled, you can see which channels are associated with which SmartPad for that setup. And then I also have some checks down here for the atmospheric pressure sensor function, whether or not the temperature seems to be functioning normal, and the power consumption. So if all looks good, you can click Stop Diagnosis, and it'll give you a little notification that this may take a while. That's okay. All right, that was faster than I expected. So some other things you can do with your SmartPad is you can enable and disable the charging field. So again, you enter your serial number, your transmission channel, and you come down here and you click charging field, disable, go, and then click OK to confirm your configuration. All right, now it's telling you that the charging field is now disabled and you are not able to charge any of your cylinders. Click OK. And now let's say if we run our diagnosis again, you can now see that the charging field has been disabled as the diagnosis has stated. All right, so we're just going to stop that again. The last thing I'm going to show you in the SmartPad tab is how to set up co-housing. So the first thing we'll do is enter our serial number for our first pad. Now the SmartPad that is stacked on top is going to be known as the primary SmartPad. It is going to provide power and charging to both of the telemeters and will also communicate with one of them. So we're going to set our current transmission channel to 2 as we had it before. And then we'll set this SmartPad to our primary pad by clicking Enable, Primary Channel 2. And then the secondary channel will be what your second SmartPad is configured to so that it can communicate with the second telemeter. So we'll click OK there. Click OK on our configuration. Okay, so we have confirmed that that's complete. I'm going to click OK. Now, unfortunately, I don't have a second SmartPad with me, but let's say I did with serial number 11089. I would enter this serial number. I would choose my transmission channel of 3, and then I would enable this secondary SmartPad on the secondary channel 3 here. And then I would click Go. And then you would be good to go, and you would be all set up in co-housing mode and ready to start recording from either 2 rats or 1 rat implanted with 2 telemeters. The last tab we haven't gone over yet is the SmartPad status tab. So if you click on that, it just pulls up a chart showing you what these lights mean on the SmartPad and what that signifies in regards to the system, whether or not it's communicating, charging, whether or not co-housing is enabled. And then it's also broken down between the different firmware versions and the different SmartPad serial numbers or model numbers for you to reference. All right, so that concludes the video portion of the presentation, and now we can open it up for questions.
Thank you for that fantastic demo, Katrina. Before we start the Q&A, I just wanted to remind everyone that the Handouts tab does have some great resources in there to help you learn more about the telemetry system that Katrina presented today. All right, let's start our Q&A session. So can you clarify how many telemeters can be implanted in a rat?
Yes. So in a rat that is above 175 grams, we recommend implanting only one telemeter at a time. If your rats are on the larger side and they are over 350 grams, then you can implant up to 2 telemeters into the same animal at a time.
And maybe you can expand on how somebody would do that.
Yeah, sure. So if I go back a couple slides, you can see in this diagram up to the right, there's some different orientations of how you want to place the telemeters. And this will also be dependent on what signals you're interested in recording, because that will dictate, where your biopotential leads go, or where your pressure sensors will go, or where your oxygen sensor or your SNA electrodes will be placed as well. But as you can see in the far right, if there are 2 telemeters that are going to be implanted, they'll both go in the abdominal cavity, and we recommend staggering them so that they're not too overwhelming for the animal. But you'll still want to make sure that the flat side of the telemeter is parallel to the SmartPad, as that's going to provide the most optimal charging. So however you decide to orient it, you just want to make sure it's parallel to the base, and you should be good to go.
Fantastic. And that would be for battery charging, correct?
Yep.
And
exactly.
best signal retention.
Correct. Mostly for battery, as the signals can communicate regardless of the orientation, but how the inductor coil is placed and located in the telemeter, if it's flat next to, or flat parallel to the SmartPad, that's going to give you the best charging.
Okay, great. The next questions also, actually the next 2 we've got are also related to the battery. So how long does it take to recharge the battery?
That is a great question. Off the top of my head, I would say that it probably takes between 3 and 4 hours to recharge the battery. So just about the same amount of time, or maybe slightly less than you would expect to get out of the battery life if it's just operating off the pad by itself.
Okay, normally it's just, if it's on the pad, it's just being constantly kept charged. Is that right?
For the most part, yes. You also, during the video, we saw while we were running that diagnosis that the charging did temporarily stop. So the pad will kind of fluctuate the power that's provided to the telemeters depending on how much is needed, which is resulted by how the data is being recorded, right? So if you have a dual biopotential telemeter, it's going to be drawing more power, and the SmartPad's going to be providing more power to it more often to keep those signals good to go and keep the battery life active. But if you have a single biopotential telemeter, it may not require as much. So the SmartPad kind of tailors the needs of the telemeter depending on where the battery level is at. So it's not 100% charging all the time, but the SmartPad communicates with the telemeter and recognizes where the battery level is at, and always ensures it has enough power no matter what.
Makes a lot of sense. Thank you.
Mm-hmm.
The next question is asking how many times the battery can be recharged, or if there is even a limit.
That is also a great question. To my knowledge, I don't know of any limit. Similar to what I said before, the telemeters are constantly fluctuating in their how they're receiving charge from the SmartPad. So that is always changing depending on how the system is running. We have seen researchers reuse these implants, take their animals on and off the pad multiple times throughout their experiments, and have used them for upwards of a year, I believe, is something that I've heard. So given the nature of how many animals that they've run through and how many times they've taken the animals on and off the pads for different aspects of the experiments, I would say, I don't want to give an exact number, but I wouldn't have any concern about the battery not being able to be recharged as soon as you put it back on the SmartPad, because that's how it's designed to work.
Great. The next question is asking if there have been any studies where their telemeters have been placed in pregnant animals, and has it had any effect on litter size or pup size?
I do not know the answer to that question. I am not aware personally of any studies that have been done in pregnant rats. That being said, that doesn't mean they don't exist. I just haven't done any literature reviews or any searches on that front. But I do know that the inductive charging of the SmartPad is designed to be at a low enough level that it won't affect the animal. I think that has mostly been tested in just normal rats who aren't pregnant. So I can't 100% say that the litter size wouldn't be affected, but that's something that I'll definitely take note of and would look into further if you'd like to reach out. And we can talk about that more after today.
Perfect. Can you measure and charge at the same time to get continuous 24-hour recordings?
Yes, absolutely. Even though you can enable and disable the charging field in the ConfigSoft software, you can leave it on for however you need to do the 24-hour recordings. And like I said, the SmartPad will do what it needs to fluctuate the charge so that the battery is always at the level that it needs to function. And you can record 24/7 for weeks at a time, as long as your data acquisition system and computer can handle that amount of data.
Excellent. What would be the max distance from the plate to keep it charging?
So for the mouse system, you want the telemeters to be 5 centimeters from the top of the tBase. And for the rat system, that inductive charging field is 7 centimeters high. So as long as it's within 7 centimeters of the SmartPad, you'll be charging.
Great. Which also loops back to the why it's better to have them implanted in the abdomen, right? So that you're closer to the base.
Yep, exactly. We typically recommend on the side of the animal in the abdomen so that it's parallel, but still within that range. And obviously the animals will be moving around their cages, but unless you have some acrobats, I can't imagine them jumping up high enough to get out of that range.
Okay, that's great. Using a 2 biopotential telemeter for recording, for example, one EEG and one EMG per rat, how many animals can you record on one computer?
That's going to be dictated by your data acquisition system. If you're using regular LabChart 8, you can only record 32 channels of data at a time. So given 3 channels of data per animal, you're looking at about 10 animals possible with that setup. We have our new software, LabChart Lightning, that theoretically has an unlimited number of channels. So as long as you have enough hardware to record all of the signals from all of your animals, the computer and the data acquisition system will probably be the limiting factor there. But overall, the Kaha system can set 40 different channels. So that's another hardware limitation, that you can only do 40 animals at a time. And if you have a computer large enough to do that, then you can record all of the signals, or your data acquisition system is large enough, you should be fine.
Great, that makes a lot of sense. Thank you. How many times can a rat telemeter be reimplanted if each use were to last 2 to 4 weeks? I'm guessing that they mean if each experiment was running 2 to 4 weeks, how many times can you reimplant the same telemeter?
We typically see researchers with that time frame get at least 4 or 5 reimplantations. There's a lab in Utah that gets more. So I would say that's more so dependent on how well you take care of the telemeters and how carefully you explant them. You'll want to make sure when you're removing them, you're not damaging any biopotential electrodes or damaging any pressure sensors. If you're careful and you take care of them, you can easily do 4 to 5 animals with that time period.
Great. And correct me if I'm wrong, you do have videos and such that kind of give tips for the surgeon on how to best take care of those telemeters?
Yes, absolutely. On our website, we have a number of surgical videos, both on implantation for different signal types, such as ECG versus arterial pressure. And then we also have a video giving procedures and tips on how to successfully explant the telemeters as well.
Perfect. Let's try to squeeze in one last question. Do we necessarily need to put a telemeter into safe mode to be stored on a shelf? And if so, why? Would you recommend any other things to do for long-term shelf storage?
So I would recommend putting it into safe mode. And what that essentially does is put the battery on the rat telemeters into a really low level power consumption mode. If the battery completely dies during storage, there is a possibility that it might have a little trouble getting recharged when you put it back on the SmartPad. We've only seen that a couple of times, but putting it into safe mode helps prevent that from happening by just making sure the battery stays pretty charged and is only drained very, very slowly, if at all. Otherwise, I would just recommend cleaning them, sterilizing them, and placing them in a cool, dry place, similar to other sensitive electrical or data acquisition equipment.
Perfect. Thanks for the detailed response. If anyone else has any more detailed questions, or if we didn't get to your question, please jot down Katrina's email or phone number that's listed on your screen right now. She would be happy to answer any of your questions or pass you on to the right person who might be able to help you. With that, that's going to be our last question. So Katrina, I want to thank you for your time and expertise today. It was really a pleasure to have you with us, and I hope that you enjoyed yourself.
Thank you very much, Sydney. It was great being here. And like you said, please don't hesitate to reach out. I'd be happy to talk to anyone else about whether or not our system would be a good fit for them.
Thank you. All right. And a thank you as well to our live audience. We know you have busy schedules, so we really appreciate you being here live, and I hope that you enjoyed your experience today. In closing, we hope you enjoyed this Inside Scientific virtual demo produced in partnership with ADInstruments, and I hope that you enjoy the rest of your day.